Okay, we are reviewing some terminology about polynomials that you've learned in previous years, and that is going to set us up for this unit. So just got some definitions. We're going to fill in some blanks. Hopefully you remember some of this. It says formula, first of all, a general rule for calculating something. So some examples. So maybe an example is area. So area of a circle is pi r squared. Maybe Pythagorean theorem. So a squared plus b squared equals c squared. And so those variables, that's the next definition, represent different values. And the word vary is in that word. Variable means, okay, so a in the Pythagorean theorem could be any length. B could be any length, and then you use it to calculate the hypotenuse, or rearrange it if you knew the hypotenuse and working backwards. But those variables can change. They can be varied. An algebraic expression doesn't have an equal sign. It's just an expression that's a combination of variables or constants, and you're either adding, subtracting, multiplying, or dividing, and there must be variables in it. So the example there is w squared plus w. That's an algebraic expression because we have the variables. The next one, 3 plus bracket 2 times 7, that's not algebraic. It's, you can either say arithmetic because it's an adjective, or arithmetic expression because there's no variables. It is always going to be that expression. Okay, and then you just perform the order of operations. So note, a formula always involves an algebraic expression. If values are substituted in, then it becomes an arithmetic expression. Terms are each part of an expression that's separated by a adding or a subtracting sign, plus or minus. So that example there, n, that's one term. There's no adding or subtracting. This has two terms because there is one adding, and this has three terms because there are two adding or subtracting signs. Okay, and so that will come up with definitions for those a little later on in this notes package. Okay, a coefficient. Those are the numbers that are multiplied with variables. So if we just look back at, say, this example, so 2L, the L is the coefficient, okay? If we look back at this here, negative 5A, the negative 5 is the coefficient. You take the sign in front. A monomial is one term, doesn't have any adding or subtracting. So it's a number or the product of a number with one or more variables, where the exponents on the variables are whole numbers. So there's basically a monomial is a particular word used to describe one term of a polynomial. Polynomial, poly means many, okay? And so a polynomial means it has many terms. I'm gonna ask you a joke. Or ask you a joke, tell you a joke, ask you a question. What do you call a parrot that flies out of its cage at dinner time? Well, hungry parrot, or how about a Polly no meal? Polly want a cracker? No meal? Okay. If he just flies out, what do you call a parrot that just flies out of the cage and never comes back? A polygon. Polly's gone. All right, so you guys need to improve your math sense of humor. But in any case, so examples here would be just what we had there. So 2L, 4A squared B, those are monomials. So things to note: if a variable is in the denominator or under the radical sign, it is not considered a monomial. It might be just one term, no adding or subtracting, but we just call it one term. We don't call it a monomial. So polynomial means, poly means many. Monomial is specific to one term. Two terms, that's binomial, just like a bicycle has two wheels. And three terms, trinomial, just like a tricycle has three wheels. That's the most specific we can get. Anything more than three terms, we just call it a polynomial with four terms, or a polynomial with 10 terms, or whatever. So no special names past that. Constant term doesn't have a variable. Okay, so here the constant term is 3. Now, getting to the degree of a monomial and then a polynomial. This is something that you may have touched on in junior high, but not so much, and it's going to be something that you need to know for Math 10C. So it's in the review, but it's something that's important we'll ask you. So the degree basically means is the sum of the exponents of the variables and the monomial. It's how many variables are multiplied together in a monomial. So here, how many variables? Well, there's A, B, and C, but there's more than one B and C. There's A. If I show this the long way, it's 3A, B times C times C times C. So in total, there are 6 variables multiplied together. So how do you get the degree? You look at the exponent on each of the variables that are multiplied together, and you add them together. You don't change the term at all, the monomial, you're just stating the degree. So the degree tells you how many variables are multiplied together. Now, if you have more than, just a note here, if it's just a constant term, it's degree 0. Because think about this, if I had 17 times x to the 0, x to the 0 is 1. This is really equal to 17. So that tells me 0 variables in that term. 17 doesn't have any variables, so the degree is 0. If it has more than one term, it's got 4 terms. So what you need to do, I call it kind of like a game. You find the degree of each term, highest one wins. The highest degree term is the degree of the whole thing. So this has a degree 3, x squared times y. This has degree 2. This has degree 1, and this has degree 0. So 3, 2, 1, 0, highest degree wins. You don't add up the degrees of each term. And so often, when we do our math questions and expand and collect like terms, we like to show them in descending order of degree. So think of descending as going downwards. So descending means the highest degree term first, then the second highest, all the way down to the constant, if you have a constant term. So this here, when we arrange this, this is degree 1, 3, 0, 2. So I take this term with the sign in front, so I have to copy out the negative 2x cubed. Then I add plus, then I have plus x squared, degree 2, plus 7x, degree 1, minus 10, degree 0. Okay, so that is descending order of degree. It's not wrong if it's not in descending order of degree, but it's proper form. And so a lot of times in math, it's important to have proper form. It also helps you when you're asked to do things like factor and that kind of thing. You need it in descending order of degree. So that's why we practice that. Okay, so we're going to do a few of the examples, not all of them. So turn over to the next page. Okay, so question 1, actually I'll let you do that. State the degree of each monomial shown. I want you to go through and state the degree. I want you to do 1 and 2 right now. And then in question 2, why aren't those considered monomials? They are one-term expressions, but they're not monomials because that is not a whole number. That exponent is not a whole number, so these are not whole number exponents. And if you remember back to the last unit, this is the same as 17r to the negative 2. So same thing there. They're rational exponents, right? A half or negative, but they have to be whole number to be considered a monomial. Okay, so then in question 3, more than just monomials here. So you count up the number of terms. So there's a subtracting and an adding. So there's 3 terms there. So there's 3 terms. Not that that really matters, actually. We're not asked for how many terms. It is a trinomial. I'm just going to put that over here. It's a trinomial. First term is degree 3. Second term is degree 0. Third term is degree 1. So the biggest degree wins. And in descending order of degree, we just have to rearrange the second and third term. Okay. Do you need some paper so you can do some of this? Next one, 4 terms. So that there's no special name for that. This is degree 0. This is degree 2. This is degree 3 and degree 1. Biggest degree wins. Okay. So in that order, that would be 2a squared b, then minus 7ab, minus b plus 4. Descending order of degree. So you need to write the degree of each term above it or below it so you can keep track. And then you always take the sign in front of the term when you rearrange it. This one, degree 1, degree 4, degree 0. So overall that has degree 4. It's 3 terms, so not that you were asked, but it is a trinomial. Okay, and then in descending order of degree, obviously the 4 is the winner. So negative t to the 4th plus 14t minus 2. Constant term goes at the end. And count up here. So this is degree 2, degree 1, 0, 3, 5. So we have 5 terms. No special word for 5 terms, but the degree is, turns out there's 5 terms and the degree is 5. Just happens that way, right? But this is what tells you what the degree of the polynomial is. So then you follow this. So that's 2m to the 5th, highest. Then cubed, so minus 3m cubed. Then squared, so plus 8m squared. Quickly. Then degree 1, so minus m, and then the constant. Oh, is it n? Sorry. Yes, thank you. Lots of m's and just one n. Yeah. Okay, so another way of describing polynomials is to talk about the degree, and the degree gives it a name. So if, for example, if it's degree 3, it's called a cubic. And that kind of makes sense, because if we say something is cubed, we would say x cubed. that's x to the exponent 3. So that word kind of makes a lot of sense. And you can see here the highest degree term is x cubed. Okay, so the degree of that polynomial is 3. What else do we have to find out about it? The number of terms in this case is 4. And the constant term is the one that doesn't have a variable. It's 8. Okay. I just skipped to that one because of the word cubic. Okay, the constant makes sense as well. We just talked about a constant term. It doesn't have a variable. In this case, it still has one term, and the constant term is 2, and the degree of that is 0, right? There's no variable there. Linear means it means degree 1, and you can look at it and see the word line. So we're going to spend a lot of time talking about lines and equations of lines and linear relations in this course. So you'll be really good at that by the end. But for right now, think about it as just being degree 1. Constant here, if we were to graph that, it would still be a line as well. But here it's degree 1. So in this case, this has 2 terms. Constant term is 5, and the degree is 1. In Math 11, whether you take 20-2 or 20-1, you're going to spend a lot of time talking about quadratics. So quadratics is degree 2. Okay, so that has degree 2. In this case, it has 3 terms. It doesn't have to be 3. And the constant term is 1. Okay. Cubic, we already went through. Quintic, those are more grade 12. 30-2 or 30-1, you'll look a lot more at cubics and quintics. Quintic is degree 4. And in this case, we have 4 terms. Again, it doesn't matter how many terms there are. Constant term is 2. But when we say how many terms there are, you always want to collect like terms. Okay? So don't leave it uncollected and then say it has 10 terms if you could really collect some like terms. Howard, do you have a question? I'm talking throughout the whole thing, so ask me. Question? Okay. All right. Now we're going to simplify polynomials. Again, review of Math 9 and Math 8, the first parts. So in order to add or subtract polynomials, they must have like terms. Simplified form of a polynomial is when all the brackets have been expanded and all like terms have been collected. And we also like to write it in descending order of degree. Okay, so here there's no brackets, but there's A's and there's B's. So you might use a different color to highlight the like terms, or I use circles for A's and underlines for B's. And now you collect them. So 3A plus 5A is 8A. Negative 2B plus 7B is 5B, positive, so it's plus 5B. Okay? So this is sort of expected that you can do this. Again, math is a bit of detective work. You have to look and have good attention to detail. Which is squared, which is cubed, which doesn't have a variable. You can only add the like term. So here, there is no other term with x cubed. So we're just going to write out 3x cubed. Notice how I put an equal sign. I noted that on some of your quizzes or your check-ins, some of you just plopping down numbers. Put it underneath, equals to, right? And each line underneath. Some of you show your work like not even in a straight line, all over the place. Each line of work underneath each other. That's the proper way of doing math, guys. Good? So then here we want to look at the x's. So negative 2x minus 4x is negative 6x. So that's subtracting 6x. And 5 plus 6 is 11. So that's plus 11. Okay. So I'm going to leave the next two for you to do on your own. We're going to go to next three to do on your own. We're going to go to F. And this one, if you look inside the brackets, there's nothing you can simplify. So simplifying in this case means getting rid of the brackets. It's called the distributive property. You have to multiply every term by that number in front. So I kind of used arrows there. You're multiplying, so that's 6x squared minus 10x minus 2. Okay, that's simplifying. Sometimes we say expand and simplify. Next week we'll do factoring, where we go from this and we go backwards to that factored form. Okay, but we're expanding and simplifying. Sometimes we'll have to remember our power laws, like in the next one. So when we multiply these, 3a times a squared is 3a cubed. Right? A to the 1 times a squared is a cubed. Don't forget, there's a 1 there. And then multiplying 3a times 7b is plus 21ab. So you have to treat everything inside the brackets the same. You multiply it by that number out front, or variable out front. Doesn't really matter, but we usually put alphabetical order. Yeah. Okay, next one. Here we have two sets of brackets. So it's 7 times x plus 5 minus 2 times 2x minus 1. So I do this expansion first, 7x plus 35. I'm trying to get rid of the brackets. So when you're expanding, don't keep them in. So now I'm going to keep the negative with, oops, what happened there? Just a sec. Suddenly my tab stopped working. So I'll try to be good with my finger here, but here, so we take the number in front, the sign in front, and expand it, and that will be our operation sign. So negative 2 times 2x is negative 4x, so subtract 4x, and then, so we've done that, and then negative 2 times negative 1 is positive 2, so it's plus 2. Okay, now you collect like terms. So do not keep the brackets in there. Expand them out, and now we have those as like terms and those as like terms. Okay, so 7x minus 4x is 3x. 35 plus 2 is 37, so plus 37. That negative in between made that last term positive. Just always remember that. Be really careful. So same thing here. We're subtracting everything in the brackets. So we have to subtract 3x and we have to subtract 4. So this one, because I have to write a little bit bigger now, I'm just going to do this. So this is going to be, I'm just going to do it down here. This is going to be equals 6x. There's nothing to do with 6x. Then we have to expand the 4 into the x, into the first bracket, right? So that's going to be plus 4x minus 12. And then here we're subtracting 3x, and we're subtracting 4, not adding 4. So be really careful on that. This becomes subtracting because it's adding in the brackets. Oh, let me do red here. So now my like terms, x term, x term, x term, constant term, constant term. So 6 plus 4 is 10, minus 3 is 7x. Negative 12 minus 4 is negative 16, so subtract 16. Okay, so you can see that we didn't do every single question. You're going to go back and do that in a bit. There's practice that you're going to do, but that's really sort of review. We're going to look at part of the next set of notes. We won't get through all of it because I want to give you a little bit of practice time. But you can see on your timeline, it says multiplying polynomials part 1. So turn to that.